for the topics we are going to cover in the rest of the semester, they are based on Razavi's book, RF Microelectronics. You can get the free copy, online copy from our library after signing. Okay. Now I want to review the symbol of power spectral density, PSD. Okay. So let's record this equation, right? Sx of f is a function of frequency, and this, if we plot it on this graph, right, that is the power spectral density, PSD. We say that if I integrate it, means we get the area under it, then we will get the FH power of the noise or the signal. So why this is the FH power? Because it is X. X can be currents, can be voltage. For example, let's assume it is voltage here, right? Voltage squared, right? For example, your voltage can have positive, negative signal due to the signal or noise, right? X is voltage as a function of time. Then you take the square, then they are all positive. And then you integrate the area, right, to get the area under this curve. That gives you the total area. But then you divide it by the amount of time you integrate. That gives you the FH power. Okay? So that's why that is how you understand this as X, the power spectral density. It is that when you integrate the area, it gives you the FH power. Okay? Not that you have the same area, right? It is that this area equals to the FH power of this signal, not the area that you integrate, right? So that is one important thing. Now, and then we say that the Sx of f, which is the PSD, the power spectral density, we can write it as Vn squared bar. Now then, why we write it with this symbol? Now, I just substitute Vn squared bar into Sx, right? I call it Vn squared bar because now I worry about the voltage noise, okay? Instead of In squared, right? N means noise. So just a pure substitution, they are exactly the same. So this is just the integration of this area. Now, let's look at on the right, which I just told you, it is the FH power. It is also the mean square of the voltage, right? Because you take the square of the voltage and then you integrate and divide it by the length, then this is the mean, right? It's just like you add all the square together and divide it by the amount of items that you have added. So this is just the mean square in the continuous sense. So this is the mean square, right? So definitely you find that this Vn squared bar is not the mean square of this signal. It is not. But it is that after you do the integration, right, we introduce this symbol Vn squared bar, so that after integration over the frequency, you get the mean square. Right, so don't get confused, right? Sometimes we may get confused thinking that Vn squared bar is the mean square of the signal. No, it is due to the power spectral density. It is just that after you integrate it, it becomes the mean square. So there's some reason, right, that why we call it Vn squared bar, which is looks like a mean square, but which is not really a mean square. It is a function of frequency. And only after integration, you get the mean square of that signal. Okay, now, I can further make this one by taking square root and square it again, right? They are exactly the same, taking square root and square it again. Now with this, then I have a new quantity, which is square root of this Vn squared bar. Now again, this one doesn't have a direct meaning, right? But it looks like root mean square, right? Because if you agree that Vn squared bar is something related to mean square, although it is not the mean square of the signal, but it is related to it because after integration, it gives me mean square. If I take the square root of this one, that is something looks like the root mean square. Again, this is not the root mean square of the signal, but just that you take the square and then do the integration, it will give you the mean square, right? So last time I introduced a symbol, I call this whole thing VNRMS, and that is the reason I call it RMS. But obviously, this has caused confusion, and some of you do not like it. And I also think that not many people or no people use this. So I agree maybe I should not do this impromptuously. So I take it back, right? But I just want to explain why I call it VNRMS. So from now on, I will only use this cumbersome notation, square root of the whole symbol, when I talk about this quantity, which is the square root of the Vn square bar. Okay, so this is the clarification of the symbol.